Okay, I've been asked to do some more problems. So, chapter 10, lesson 8. Here we go. I also have a tech question for all of you because I am using YouTube and I'm recording. And I would like to turn the screen around and have the camera look at me the other way. But when I do that, it looks like I'm writing backwards and everything's upside down. So, if you could help me, that'd be great because this is a little awkward and uncomfortable to do it from this direction. So 10.8, number 33 looks like this. I needed a little change, so I'm using a whiteboard. 8 to the third plus 6a squared. 8 to the third plus 6a squared minus 4a minus 24. Don't worry, I'll move it so you can see it. All right, so notice you have 4 terms. When you start to factor a polynomial and you notice that it has more than 3 terms, you need to separate it into sections or parts. So this is somewhat like when you have a trinomial and there's a leading coefficient other than 1, and you get to that part where you have 4 terms and you separate the first 2 from the back 2. So I need to factor out the greatest common factor from the front 2 terms, which they would both have an a squared. Once I factor that out, I am left with a plus 6. So I'm going to get an a plus 6 over here. Looks like I'm dividing by a negative 4. Ah, you can't see all that, can you? I don't know. I feel like I'm talking to myself. Okay, so the a squared minus 4 comes together. One set of parentheses. And the a plus 6, other set of parentheses. Some of you might have stopped here. But if you take a look at this right here, a squared, that's a squared minus 4, that's difference of squares. So you can take the square root of a squared, and it's just a. Square root of 4 is 2. Change that into a plus 2 and a minus 2, and then rewrite your a plus 6. Okay, so this is my factored form. There are 3 factors. I know a lot of the times we only have 2. This is part of section 8 because it's the whole factor completely. So we have, in the most part of the chapter, been, factoring, and then once you get your 2 binomials, you can't factor any further. But here you got to take a look. Can you keep going? Is there anything else you can do? And we could factor this further into the a plus 2, a minus 2. Okay, so that is number 33. Okay, 35 was also asked. So I was all prepared on the last one. We'll see what this one goes, okay? 3m to the third minus 15m squared minus 6m plus 30. Same process. Separate the front 2 from the back 2 and factor them separately. Alright, so out of the first binomial, when you take the 3 and the 15, you can divide them by 3. M to the third and m squared, I can take out an m squared. If I am dividing by this, for this first term, I will have left an m, because 3m squared times m gives me 3m to the third, minus 5. Because 3m squared times negative 5 will give me negative 15m squared. Again, this is going to be the same, m minus 5. So it looks like I'm dividing by that negative 6. These come together. 3m squared minus 6 and m minus 5. But you have to keep asking, can I keep factoring? Can I keep factoring? Is there anything I can still do? And when I look at this, there is still a common factor for the 3m squared and the negative 6. You can take out a 3 and be left with m squared minus 2 and m minus 5. And then that's what your answer would be. That is factored form, factored completely. M squared minus 2 is enticing. It looks like it's difference of squares, but the number 2 is not a perfect square. If it was a 9 or a 4 or a 16, you could keep going. All right, so that's 35. I'm sorry, that was 35, if you want that. Okie dokie. Number 41. I know why 41 was disliked. Actually, this section is kind of irritating. But 27, I didn't write the book, plus 6w minus w squared equals 0. You can reorder this. You can change this around. So let's say I wrote negative w squared plus 6w plus 27. Any rules that you've learned with math, you can do if you want to change how a problem looks. I don't like having a negative 1 outside my w squared. I'm going to take out a negative 1. Factor it out. Divide everything by a negative 1. That'll make my w squared positive, but my 6w negative and my 27 negative. Okay, so the question, I guess, is solve the equation and tell which solution method that you used. So I'm going to see if I can factor this. There's no number in front of the w squared. So my question is, are there two numbers that when you multiply them together, you're going to get a negative 27, and when you add them, you're going to get a negative 6? Two numbers, like 9 times 3 maybe. So negative 9 and positive 3 add together to make negative 6 and multiply to negative 27. Okay, so when you're factoring, that negative 1's going to stay out there. Your two numbers are negative 9 and 3, positive 3. It does say to solve this. So what value for w is going to turn that into 0? Positive 9. What w value would turn this into 0? Negative 3. There's your solutions, 9 and negative 3. All right, that is 41. 45, 47, and 49 are all similar. They probably stumped you. The directions, remember, says solve it, and then it says tell which solution method you used. Keep in mind that not everything is factorable, and that the discriminant b squared minus 4ac is a great tool to tell you whether or not something can be factored. So 45 says 10x to the third minus 290x squared plus 620x equals 0. All right, so 45, when I take a look at that, I say, is there a greatest common factor? Something you could divide everything by. And I'm seeing everything ending in a 0, so that would tell me I can divide everything by 10. I also see at least one, or an x to the first power, and a variable of x in each term. So I'm going to take out a 10x, or divide everything by 10x. Tempting to try to factor this. on 45 because you're thinking maybe that 31 times 2 makes 62. And then when you were to add them or subtract them together, maybe you would get a negative 29. But in order to get a negative 29, that means that one of the numbers would have to be positive and the other one would have to be negative. And if that's true and you're multiplying, you're not going to be able to get a positive 62 right there. So on number 10, like let's say you're just trying to find those two numbers, but if you do b squared minus 4ac, and I do negative 29 squared minus 4 times 1 times 62, I get, I think 593. If you want me to do that all the way through, I can. So let's check that. 29 squared is 841 minus, and then 4 times 62 should be 248. Let's see, 248. 4 times 62. Yeah, 248. So 841 minus 248 is 593. Take the square root of it. So second square root 593. That is not a perfect square. Not a perfect square. That means it's not factorable. If it's not factorable, you must use the quadratic formula in order to solve your equation. So, quadratic formula only for this part. So negative b plus or minus square root of b squared minus 4ac all over 2a. Opposite of b will be positive 29. We already did the b squared minus 4ac to see if it was factorable. We got 593 all over 2 times a, which is 1, so just times 2. So what does the answer look like? It looks like that. Okay, so it has 3 answers in the back of the book, though. So when you go back and you look at the red part of the problem, this 10 is a factor, this x is a factor. Look, you know, like if I wrote 10 times x times this right here, so 1, 2, 3 factors, what makes this 0? It's kind of a goofy question, but 0. So 0 is also one of your solutions. If you make x equal to 0, no matter what this is, because you get 0, 0, you get 62, right? 62 times 0 times 10 is still going to make 0. So one of your solutions is 0. Your other 2 solutions come from this. If you were to use your calculator, 29 plus the square root of 593 over 2, and 29 minus the square root of 593 over 2. So by writing this like I have done right here, I'll circle it in red, this is actually 3 solutions, okay? 1 because of the plus sign and 1 because of the minus sign. Okay, so that's 3 different answers on 45. '47 is super similar to that one, so if you could try 47, I'm just going to tell you to use the quadratic formula. See if you can do 47. 49, the same thing. I will do 47 and 49 if you email and ask me to, but maybe after doing 45, those will make sense to you. So I'm going to finish with 51. 51 looks like this, and it says on Earth, and then there's 2 formulas for model. Model the one with Earth. H equals 16t squared minus vt. Okay, this looks different than things that we have been normally using, or formulas we've been normally using. There's no plus s on this one, and it says that h is the initial height. So h is not your ending height in this case, it's your initial height. So on Earth, you toss a tennis ball from a height of 96 feet. That means this is your 96 feet. with a velocity of 16 feet per second. So this v is going to change to 16. And we're supposed to solve it for the amount of time. So I have to subtract the 96 because solving means you got to get y equals 0. So subtract the 96 on both sides, minus 96. So I have 16t squared minus 16t minus 96. Big numbers. I don't really want to do 16 times 96. So my guess is that maybe I can either divide 96 by 8 or by 2 or by 16. I'm going to try 96 divided by 16. And I get 6. So hey, what do you know? I'm going to divide 16 out of that whole thing. T squared minus 1t minus, and I just said that 96 divided by 16 is 6, equal to 0. This is factorable. There are two numbers that multiply together to give me a -6 and add together to be a -1. Those two numbers are a -3 and a +2. So if I'm solving again, I have to find the value for t that will make these two factors equal to 0. So what do I put in here? What minus 3 makes 0? 3. T equals 3. What would turn this into 0? T equals -2. One of these doesn't make sense for time. So your answer is going to be 3, and it is in seconds. So there you have it. That is number 51. Again, if you have problems with numbers 45, 47, 49, or whichever ones I didn't do, please let me know. I certainly can do them. Oh, there's my puppy dog, Bella. 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 There she is. All right, she's saying bye. Stop. Over and out.